Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Settling Differences by Sudoku, and here are the rules. We have normal Sudoku rules apply, that is, each row, column, and 3x3 region has to contain the digits from 1 to 9 once each. And we have killer cages, where digits in a cage do not repeat and must sum to the clue in the top left. So, for example, if this were, say, a 3, this would have to be 7, because these two digits must add up to 10 because they are in a killer cage, which has a 10 in the upper right-hand corner. So, or upper left-hand corner. Yeah, upper left-hand corner. So they have to add up to 10 then, because of that. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, first one I see is the 5 digits, which add up to 15. And you have 1 through 5 here, because digits in cages do not repeat. That means the remaining digits in this box are 6 through 9, because of the 1, 2, 3, 4, 5 quintuplet in the box. This, to add up to 10 for 3 digits, you can have at most a 6 or a 7. So you're guaranteed, so if you have 6, this is 1, 3. If you have 7, this is 1, 2. Either way, there's guaranteed to be a 1 here. So this cannot be 1 here. To add up to 11, you could have 6, 7, or 8 here. 8 can be with 1 or 2. 7 can be with 1 or 3. And 6 can be with 1, 4 or 2, 3. We're not sure which. Okay, to add up to 6, you have 1, 5, and 2, 4. To add up to 20, you have to have 3 through 9. To add up to 10, you cannot have 5, but that's not very good. Okay, what are the sum of all of these cells? We have 12 plus 13 plus 11, which is 36, plus 10, which is 46. So 46 amongst all these, and then you can have at best a 9 there. So 46 plus 9 is 55, which means these 4 digits add up to 10 at most. Interesting. So that means, sorry, for all 4 of them. So you have 1, 2 here at best, and you have 1 through 6 here. Well, you're guaranteed both cannot be 1, right? If you have 1, 2 here, you cannot have a 1 here, because that would eliminate 1 from all of these cells, which is impossible. So, again, 36 for all the cages here, and then plus 10 is 46, plus 9 as a digit is 55, and 55 minus the 45 with the digits 1 through 9 here gives you 10 here. So if you have a 1 here, you cannot have a 1 here. So if this is 1, 2, this would be at best, you can't not have a 2 either. You would have to have 3 and 4 here. So if you have 1, 2 here, this would have to have 3, 4 here. So these all have to be unique digits, because you can't have 6, 1 here and 1, 2 here. And then all of these would be 1 through 5, but you cannot have 1 here and 1 here, because that would eliminate 1 from the rest of this cage here, which has to have 1, 2, 3, 4, 5. So you can't have unique digits here, because if you had repeat digits here, say you had a 1 here and the only repeated digits you can have are 1 through 2, I think. Can you even have 3 repeated? I guess you could have 3 repeated, but it's still problematic, right? Because you have to have a 3 in one of these 5 cells. So these cannot be repeats here, because any repeats would have to be at least 1 through 5. So since you can't have repeats, these have to be 4 uniquely different digits, which add up to 10, which is guaranteed to be 1 through 4. So you have 1 through 4 here and 1 through 4 here. Well, that means in the rest of row 4 and column 4, you cannot have 1 through 5, because we have a 1 through 5 quintuplet in each of those boxes. Therefore, this must be 5 here. No 5 here, no 5 here, no 5 here, no 5 here. And we have a 1 through 4 here. So these two digits must correspond to these two, and these two digits must correspond to these two. Therefore, we're guaranteed a 9 here. This has to be 6, 7, or 8, and this must be 6, 7, or 8, which means it's 1, 2, 3 to add up to 9 there, and 1, 2, 3 to add up to 9 there. We have a guaranteed 1, 2, 3 now, triplet, in column 5, which eliminates 1, 2, 3 in the rest of the column. This can't be 2, 3, it's 4. That eliminates 4 in the rest of the box and row. And we know this has to have a 1, so this cannot be 1 here. This is 8. So this is 4 here, which means 4 is one of these two. We again have a 1, 2, 3, 4 quadruplet in row 5, which means you cannot have 1 through 4 in the rest of the row. So this is guaranteed to be a 4 here. The only 4 that you can have here is 1, 4, and 6. So this has to be 1, 4, and 6 here, which means this can't be 6, that's 7, which means this cannot be 1, 3, 7. It's 1, 2, 7 to add up to 10. So this can't be 6 or 7. No 6 or 7 here. 2 eliminates 2 from being here. So this is 3 and 6 adding up to 9. That eliminates 3 from either of these cells, which means these digits must be over here. So this cannot be 3 here. 3 has to be one of these two. 3 has to be one of these two. So this can't be 3. It can't be 1. It must be 2 here. So this is 2 and 7. This can't be 2 or 1. It's 3. Which means this can't be 3, no 2 here, which means this can't be 1 here, so that's 2, 4 as a pair, which forces this to be 1. That eliminates 1 here, so that's 2. This cannot be 1 or 2, so it's 4, 5, which means this can't be 4, 5, it's 1 or 2. Okay. What are the possible combinations here? 1 and 2 would have 10 there, so that's not possible. 3 and 2 has to have 8, right? Yeah, 8. Oh, this is 2, 4, which means this cannot be 2, 4 as a pair, because that would eliminate all possibilities for that cell there, so it must be 1, 5 here. Which means 5 cannot be any of these digits, and 1 cannot be any of these digits. So again, you could have 1, 4, 8, 3, 2, 8, or 3, 4, 6. So those are the possibilities there. Remaining digits of column 4 are 7 through 9. Remaining digits of column 5 have to be 5, 6, 7, 8, 5, 6, 8, and 9. And this can't be 8 or 9 because of the 7, 8, 9 triplet in the box, so this is 5 or 6. Actually, 6 eliminates all possibilities for 6 there, so 6 has to be here. Which makes this a 5, 8, 9 triplet, which eliminates 5, 8, 5 in the rest of the box because 5 can't be here. So therefore this can't be 5. This is 1, which makes this 5. Remaining digits of box 8 are 3, 4, and 5, which makes this combination 7, 8, and 9. 9 can't be here because of 9 in the row. Okay, 6 can no longer be here. Remaining digits of row 4 are 6, 8, and 9. Remaining digits of row... Well, we have left in box 6. We have 2, 5, 2, 3, 5, 7. This cannot be 2 or 3. 7 cannot be here, so it's 2, 3, 5 as a triplet, which eliminates 2, 3, 5 in the rest of the box. So this is not 5, this is 7. 2, 3, 5 eliminates 2, 3, 5 there, so this is 4 and 2, adding up to 6. 2 eliminates 2 here, so it's 1 and 2 there. Where is 2 in row 9? 2 cannot be here because of 2 in the boxes, and 2 cannot add up with 2 other unique digits to add up to 20, so 2 has to be here. This can't be 2 or 5, it's 3, which eliminates 3 here, no 3 here. This can't be 7 because of 7 in the column. Remaining digits in row 5 are 5, 8, 9 again. Remaining digits in row 6 are 6, 8, 9. And this can't be 9 because of 9 in the column. Okay. 11. 10 can only be 1, 2, 7, 1, 3, 6, 1, 4, 5, or 2, 3, 5. But there's no 2 or 7 here. There's no 3 or 6 here. 2 and 4 cannot be here. 2 and 4 both cannot be here, though. So this 10 requires either a 2 or 4 in it. So it's either 1, 2, 7. It cannot be 1, 3, 6 because that does not have a 2 or 4 in it. Because it can't be 2, 4, and 3 at most, which adds up to 9. So this could be still 3. Right? Because you could have 1, 2, 7, 1, 4, 5, or 2, 3, 5. Okay. You cannot have 1 and 5 here. So this couldn't ever have 2 and 4 in it because that requires 2, 4, 4. But this could have 1 and 5 here. You're not guaranteed that. Let's see. This has 2 or 4 in it. This has 2 or 4 in it. If it's 2 here, this is 1, 4, 5. That seems okay. We do know 2 has to be one of these 3 digits. Right, this can't be 2, 4 either because that would eliminate 2, 4 as possibility there. 5 eliminates 5 there. So where's 5? In box 2, it must be here, which eliminates 5 from being here. So if this has a 5, it's 2, 3, 5 there, or it's 1, 4, 5 here. So 4 can never be here. We are guaranteed a 5 in one of these cells here. If this were 5, that would force this to be 2, 4, 2, 4 to add up to 11 here. And that's not allowed. So this cannot be 5 here. This is guaranteed to be 5. Again, that can't be 2, 4 because of the 2, 4 pair in the column. So this is 5, which is either 1, 4 or 2, 3 here. 7 cannot work. So this cannot have a 3. This could be 1, 4, or 2, 3. We are okay, so 5 is there. This cannot have 2 and 4. So these cells must have 6, 7, or 8 remaining because 6, 7, and 8 cannot be in this set. Therefore, they can't be both in this set, both here or both here, because 6, 7, and 1 adds up to 14, doesn't add up to 13, again, doesn't add up to 11. So this has to have 6, 7, or 8 here. Well, you could have 6, 2, 3. Can you ever have a 4 here then? 4, 6, and 1 does work. But if you have 4, 1, 6, that would force this to be 3 and 8, which is over. I guess 3, 8, 2 does work. Okay, never mind. So this must contain 6, 7, or 8 here. This must be a 6, 7, 8 here. Obviously no 7 there. 6 can be with 4 and 1. So 6 can't be here because of 6 in the box. So it could be 6, 1, 4. 6, 2, 3 does not work because of the 3, 6 pair being there. 7, 7, 2, 2 doesn't work. 7, 4, 1 doesn't work. So this has to be 6 or 8 here. 8, 2, and 1 work. So this is guaranteed to have a 1. Because this has, so one of these is 1. Since one of these is 1, this cannot be 1, 4. It has to be 2 and 3. So we have 2 and 3 here. This contains 1, 6, and 8, so that eliminates 1, 6, and 8 in the rest of the box, and we're left with a 7. So this must be set 2 eliminates 2 here, so it's 4, which makes this 1 and 6. Which makes this 8, 2, 8, and 3, which makes this 1, 7, 4. 8 eliminates 8 here, so it's 9. No more 9 here. 9 eliminates 9 here, so this is 8, which makes this 9. No 8 here, no 5 here, so this is 9. No 8 or 9 here, so it's 5. And no 9 here. Remaining digits in column 3. We have 7 and 9, which eliminates 7 and 9 from this cage. So no 1, 9, no 3, 7, no 2, 8. This has to be 4 and 6. This can't be 4 because of 4 in the row. So this is 6 and 4, which eliminates 6 here. So it's 8 and 6. That eliminates 4 here. No 4, 6 here. There is no 6 in this 20 cage. Remaining digits in row 3. We have 3 and 6, which eliminates 3 and 6 in the 10 cage. That means this can be 1, 9, 2, 8, no 3, 7, or 4, 6. But 1, 9 can't be here because both 1 and 9 are there. So this cannot be a 1, 9 pair. It has to be 2 and 8. 2 cannot be here because of 2 in the row. So this is 8. This is 2, which makes this 5 and 2 there. No 5 or 8 here. 8 eliminates 8 here, so that's 7 and 8 there. We have all the 2s set, right? Yep. Remaining digits of column 1 are 1 and 5. 1 can't be here because of 1 in the row, so this is 5. That's 1, which eliminates 5 there. Remaining digits of column 2 are 3 and 4. Wait, that doesn't work. Hold up. Well, okay. This is 6. This is 4. I don't know how I did that. Anyways, this is 8 and 6. This still does that. So these are all still the same. This is 2 and 8. This is 2 and 8, which makes this 7 and 8 there. This is 1 and 5 still. This is 5 and 1. This has to be 3 and 8. So this is 3, 8 remaining. This is 3 and 6 because of the 2, 8 being here. We have 4 and 7 left. This can't be 7 because of 7 in the column, so this is 4, that's 7. No 5 here. Remaining digits of row 2 are 1 and 9. That seems fine. 4 eliminates 4 here. So what are the possible well, 1 cannot be here or here and can't be in the cage, so 1 in box 9 has to be one of those two, which means we have a 1 guaranteed in column 7 and 8 in both box 9 and box 6, which eliminates 1 then in the rest of column 7 or 8. So that's 9, that's 1 there. This cannot be 9, no 8 here. So to add up to 20, we have 3, 8, and 9. You cannot have 6, so you could have 4, 7, 9, but the problem is both 4 and 7 would have to be here. So there's no 4 allowed here. 5 can be 5, 7, 8. And 8 eliminates 8 from being here. So 3, 8, 9, or 5, 7, 8. Either way, 8 has to be here. So 8's guaranteed here, which means this cannot be 8 here. Where is the 8 in row 4? It must be there. Remaining digits in column 7 are 1, 4, and 6. This cannot be 6 here because of, and it can't be 4. So this is 1, which makes this 4, which makes that 1, which makes that 6. No 1 here. Oh, I don't have 2s. 5 and 2. How did I miss that? Anyways, this is not 5. Where is 4 in row 9? It can only be here. So that's 4 here, which makes this 3, which makes that 5. So there's no 5 there. 3 then eliminates 3 here. So this is 8, which makes that 3. So that eliminates 3 from being here. We have a 7, 9 pair in row 9, which eliminates 7, 9 in the rest of the row. This can't be 7 or 9, it's 8. This can't be 8 or 9, it's 5. 3 cannot be with 5 to add up to 20. So this has to be 5, 7, and 8. Which means 7 can't be here. This is 9, that's 7. No, 8, 7, or 8 here, that's 9. Which forces this to be 7. Well, remaining digit in row 8 is a 3, which makes the 6, which makes that 3, which makes that 9 and 6. That leaves that as a 9 and that as a 4. And that's how you solve it. Fairly straightforward. This was the interesting part, right? This was the real break-in here, where you realized you could not have duplicates here. And that really broke everything apart. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.